Welcome to Season 2, Episode 6 of the 6 M's of Manufacturing podcast. I'm your host, Adrienne Temple. In this episode, we are talking about collaborative robots and process automation with Chase Wentzky, a robotics specialist at Motion Automation Intelligence, or Motion AI. Chase holds a master's in mechanical engineering from Clemson University and has also had research experience with the National Science Foundation and the Advanced Robotics for Manufacturing Institute. He also serves as a certified collaborative robotics trainer in various industries in the Southeast. So, stop, collaborate, and listen to this episode. Chase, first of all, just want to welcome you to the show. Thanks for joining me today.
Yeah, thanks for having me, Adrienne.
So let's talk a little bit about cobots. That's kind of, I think, a buzz term we hear quite often whenever it comes to Industry 4.0, and cobots are a solution for a lot of things and automation is a solution for a lot of things. But let's kind of disseminate cobot versus the industrial robots we're traditionally used to seeing in a lot of different operations, especially large organizations. Talk to me a little bit about those differences between cobots and industrial robots.
Yeah, absolutely. So essentially, you think about a collaborative robot that you're used to seeing at a trade show or in somebody's manufacturing facility. You think about a 6-axis robot, right? The articulated arm that we're all used to when we talk about robotics. That design and that functionality is essentially the same, right? The difference between a cobot and traditional industrial robot is basically how this robot knows where it should be going and when, and how much power it should be consuming, things like that. So essentially, the kind of breakthrough that cobots represent to robotics was really the ability to monitor, again, like, should I be seeing this much resistance or should I be seeing this much current draw in all of these motors that I have? And somebody said, hey, we could actually do the math on this. We know how much current these motors are going to draw in this robot based on things, like kinematics. And if we're going to go back to physics class and things like the mass of the stuff you're picking up. So if we see current much higher than that, we can tell the robot to stop, right? Which, again, makes the big difference between that and traditional industrial, which is that, a large 150 kilogram payload robot with hydraulic motors, if you tell it to go to point A to point B, and there's anything in between point A and point B, it's going to go straight through it, right? So it's going to go where you tell it to go. Cobots, on the other hand, have the ability, either with, like I said, the current draw, the motors, things like force sensing. They can say, hey, I think I've run into something here, which, makes a big difference for manufacturers, whether that's protecting, equipment, the parts they're making, but more importantly, the people that are working in that area. It opens up kind of a whole new world for what you can automate and how you can automate it.
What types of things, when you look at cobots in general, and kind of, since you do a lot of those types of projects with different clients, all over, what are some of the things that you find are common misunderstandings or, things that people really are unsure of when it comes to cobots when you have that conversation? What kind of resistance do you run up against, or what do people truly not understand about a collaborative robot in their application?
Yeah, I think the biggest one that I spend the most time walking back, if you will, is that inherent safety, right? So a cobot does have that base layer of inherent safety, right? So just out of the box, all other things considered equal, a cobot is going to be safer, around your operators, around your maintenance technicians, or anybody in your plant, just by virtue of the technology, right? So just in and of itself, it will be safer. However, that doesn't mean the robot is automatically just throw it anywhere you want. Everybody can play around it and be as close as they want. There still is plenty of questions to be answered on a case-by-case basis. And really that current monitoring, that we call it a protective stop with our robots, that, again, is a great foundation, and it gets you a lot further past the starting line in terms of safety. But that's not the only thing, right? So, all the time when we have, a new project with someone and they're asking about safety, how we're going to guard this thing, it really all depends. What's going to be on the end of arm tool? the running joke is if you put a hot knife into a collaborative robot, it's probably not all that collaborative, right? In the sense that you want people near it. But even then, it's just like any other piece of equipment you'd bring into your plant, right? So let's say you're a manufacturer and you're bringing in, 5 new lines and 5 new machines. Your EHS folks would be involved in that process, right? And the same goes with collaborative robots. Just because it's a fun new piece of technology doesn't mean you don't need a risk assessment, or it doesn't mean that your environmental health and safety folks wouldn't have some input into that process. And so, like I said, things like what's on the end of arm tool, how fast is the robot moving, how close are people expected to be near it, how much is being communicated to operators in that area about this system, right? All of those things go into your risk assessment to understand, okay, do we need to have a light curtain guarding this area where the robot is? Does the robot need to have a safety area scanner on it so that if somebody gets within X feet, it can either run slower, or if somebody gets really close, it can stop. That inherent layer of safety, like I said, gets you, in my opinion, miles ahead of what you would face if you were implementing a traditional industrial, but it doesn't get you all the way to the finish line. So that's probably the biggest one I see.
That's a good point. When you think about moving from industrial robots that tend to be enclosed in a cage and you don't interface with it, now you're getting into a collaborative space, and how you're going to interface with it. And to your point, all of those safety measures is really something that people should be cognizant of, just because it is truly collaborative, right? You're supposed to be somehow interacting with it, and safety is always the biggest concern for a lot of folks. Let's talk a little bit about, because many times what I find is, you find a problem and you go, maybe we should put a cobot in, right? You go from, maybe I've got an operation that's, repetitive, or perhaps I'm having trouble from a staffing standpoint in certain types of jobs. Maybe I should get a cobot, right? Because it seems probably that's relatable. The question being, I'm sure it's not a one size fits all type of thing. There might be places where cobots really don't apply. There are certain operations probably that lend themselves to a collaborative robot. Can we talk a little bit about maybe the most favorable applications, or where you are doing a lot of work in that space and it's a really good fit from, like you said, all around safety, productivity, and actually the payload or whatever it's working with, right? So let's talk a little bit about that.
Yeah. So, I think generally speaking, probably the largest application that we see are just different kind of iterations of pick and place, right? So whether that's transferring product between conveyors or something like that, palletizing boxes, really light assembly, those situations where you can basically emulate what a person was doing, is really kind of the sweet spot. I think where people tend to get in trouble with cobots from time to time will be really high speed applications. So the cycle time is really, really low, or we want to automate this, and now the cycle time is going to be, cut by a factor of 4 or something like that. The robots, another word for a collaborative robot, is a speed and force limited robot, right? And the whole point of the speed and force limited part is for that inherent safety. And so typically we'll have people say, hey, we want to automate this. We really like cobots. This is really exciting. And our cycle time is 2 seconds, right? We need to move 2 meters in 2 seconds or something, right? Again, we can look at it, we can simulate it, we can study it. But in that situation, the conversation is this really the best fit for your application, right? Are we starting with a solution and then finding problems, or are we starting with a problem and finding a solution? And that doesn't mean that thing can't be automated. It just means it needs to be automated differently. And then that's when you go and look and say, okay, what's your floor space requirement, right? One of the biggest advantages of a cobot over traditional industrial, in my opinion, people talk about, well, you don't have to invest in all the fencing and all these things and whatever. But I think not having the fencing or not having some of this other required precautionary stuff really saves you a lot of floor space. So really, when you look at that area and you say, hey, I need the cycle to be 2 seconds and I need it to fit in a 3 foot by 3 foot space, the question really becomes, okay, well, what are the other options here? Is this something that we can do on this line, or is this going to be a larger undertaking where automating it might not be as simple as just dropping a robot in the spot where someone else used to stand, right?
Sure. When it comes to the limitations of maybe payload or things like that, is this something that could potentially be scalable within cobots from a essentially a tabletop small unit to what's the range? I guess at what point are you kind of getting outside of the abilities of a collaborative robot? Maybe you need to look at other options, not only on the speed side, but now what about the payload it's handling?
Right. So interestingly enough, this has been something that's been happening in the robotics industry over the past 3 or 4 years, really, is we're really finding with both, again, the ability to monitor current and the ability to stop the robot and continue to make it a safe product. Um, the robots keep getting bigger and bigger, right? So one of the kind of leading players in this game is a company called Universal Robots. They were kind of the first company really out there with a collaborative robot back in 2015. And now, 5 generations of robot later, they have a UR30, which is a 30 kilogram robot, right? So not exactly the payload you think about when you think about, a small little speed and force limited cobot, right? In addition to that, the robot is actually in this 5th generation about a half meter a second faster in max speed than the previous robots. So if force equals mass times acceleration, and what we're worried about here is force, obviously at some point we're going to run up against a theoretical limit there, right? And you could always go heavier, in the sense, and I think there are some companies exploring that, but you would have to move slower. So really, to answer your question, I think that, again, as long as the technology and as long as that inherent safety continues to be kind of the driving factor with cobots, I do think you're going to see, you know, bigger, faster robots that are still collaborative. And in one sense, there's also companies out there taking a totally different tact where they're not just doing, things with, like I said, motor current, but they're even like guarding the robots with these sleeves that can sense human touch, right? And so, there's all kinds of different things on the horizon of what could be next. But I think it's easy to forget that this technology really is still less than 10 years old in terms of a commercial, viable product manufacturers use. So,
what are some of the benefits? Because you talked about obviously floor space, the ability to kind of put something in place and work around it in your current layout. But what are some of the benefits to someone integrating a cobot into their current manufacturing process? What are some of the things that you're seeing that people reap from making that investment and doing all the due diligence to put it in place?
yeah. So I guess, on the one hand, there's just the general benefit of automating anything, right? So in the sense that you're making your operations more efficient, in the sense that you're able to free up your operator resources to go and do other higher value add tasks. I think there's a baseline level of benefit that's just simply coming from automating things, and that's a trend that's not slowing down. I think a lot of firms see themselves in kind of an automate or else situation. And so I think everybody's clear on those benefits. I think the thing with cobots, and particularly kind of the experience of bringing this technology into a facility, is one, it's extremely approachable, right? So I think one thing that I always see and I've seen in my career thus far is, the inherent safety is great, the floor space savings are great, but I think the light bulb really goes off for a lot of manufacturers when they sit down for a training or we go on site for a demo and we show them, hey, this is how essentially, in a very short amount of time, I can show them, hey, this is how this robot's programmed. Obviously, there's a lot of the devil's in the details, and that takes up a lot of time. But just people saying, I never thought I could get a grip on how, a robot would work or how I would make it work in my facility. And the fact that within, minutes to hours, they're sitting there on the teach pennant programming it. And a lot of that's related to things like no code programming. So you're not going back to school and learning a brand new coding language or anything like that. You're really dragging and dropping little function blocks on a screen, and that's I think the company I mentioned earlier, Universal Robots, has done a really great job of that. They're not the only ones out there taking that tact, which probably speaks to the benefit of that whole no-code programming. But I think companies being able to grasp something like this and then also retain the in-house knowledge to do that, right? There are plenty of times and places for full turnkey systems, totally, especially if the challenge is really complex. But one of the things that might be lost there is that if you didn't kind of go through at least the initial struggle of setting that up or designing it, you just don't have the institutional knowledge that you would have otherwise if you were able to kind of run the project from start to finish. And again, with cobots, with the programming interfaces again being more and more accessible, I think companies are reaping a lot of the benefits of really understanding what's going on in this program, what's going on in this technology, and how does it work.
I can personally say I would be thankful for no code. That was not my strength in college. So I would be very thankful if it's something that's a little bit more drag and drop, which again is more user friendly for sure for people that are coming in and don't have a maturity level in coding itself. So I'm sure that's definitely an over benefit for a lot of folks, makes it more accessible, right? A good question though is, help me understand when you start interfacing with clients about a potential cobot opportunity, what got them there? What got them to that critical decision point? They were even considering this type of implementation. What problems were they typically trying to solve, or how did they get to that point that they're ready to really consider integrating a cobot into their operation?
Well, the easy answer is millions and millions of dollars of marketing, right? No, really, I think cobots, I mean, I joke about that, but I think the collaborative robot industry at large has done a really good job of making sure people are aware that, the only road to automating something is not, again, blowing up your whole floor plan and having to, like I said, just put a big desert right in the middle of your facility where, hey, this whole thing is locked out. If you open this door, the whole line shuts down, right? I think that the robotics industry at large has done a good job of making people aware of cobots. And like you said, you don't, or like we talked about, we don't really want to start with a solution and then try to cram it into some problem somewhere. I think that's a recipe for failure. But typically, people say we want to automate this. We don't really. Sometimes they do have a very specific bent towards cobots, and if it's a good cobot application, then great. But if we take a look at it, and again for things like cycle time or kind of forces involved for doing the assembly, right? We can help steer people away from that, and that's kind of our role as an automation distributor to on the front end say, hey, I think we're going down a good road or not. But a lot of times people just say, hey, I want to automate this, but I can't really change anything else, right? I had a project earlier even this week with a company that makes custom machines, and they basically just want to have a robot do some of the unloading tasks. And for them, they spend all this time and money developing this beautiful, great machine, and developing a system where an operator will stand at the end of the machine and do some of the packaging at the end. And they said, look, we really don't want to blow up everything we worked to create here. So a cobot seems like a natural fit because more or less we can drop it into the system, and with really minimal changes, we can emulate what the human operator was doing prior. So I think that's a big thing. I think people, not that cobots don't represent a big change for manufacturers when they start bringing robots into the facility, but they certainly can I hate the phrase plug and play, but really gets close to that in the terms of, again, we're not having to eat up all this floor space with, guarding and all kinds of other infrastructure that are required for a traditional industrial. The nice thing about a cobot is that for the most part, and particularly the ones that we represent and work with, they plug into 120, like into the wall. You throw it on a stand, and for the most part, you've kind of gotten your floor space requirement, right? So I think that's probably one of the biggest ones is how can we integrate something into our operation without blowing up what we already got going that's good.
What kind of ROI do you see with some of these projects? I mean, I'm sure that comes up, right? I mean, obviously, there's a problem statement. There's a very clear picture of what we're trying to solve, and we know what we have involved in that. But whenever you make an investment with a cobot, what kind of ROI do you typically see with that? I mean, how quick is the return on that? And I'm sure it's probably specific to the size and scale of the problem, right? But I mean, what do you see with that typically in some of those engagements to get people's mind around how this could benefit them and how quickly it can provide that return based on maybe the problem at hand?
Yeah. So I think people traditionally look at ROI and they basically just say, okay, what's your labor overhead in this area? And if you replace that with a robot or a series of robots or a system, there's your ROI, right? But to me, that's definitely one part of the equation. Um, but people also don't think about things um, like what's the cost of not producing, right? So let's say you have an area or you have a highly skilled individual in an area, um, and that person calls out sick or can't work on that for some reason or has to be pulled into something else. Like, what's the cost of not producing that material, first of all? Um, and then second of all, you think about things like quality, right? If a cobot can come in and people are hoping for much faster speed and whatever, and they're like, oh well, the cobot does it about the same speed a person does it. Well, if the cobot's doing it, at a higher quality than a human operator might do it, well, your throughput is still going to increase, regardless of the speed that the robot's moving at, right? So all other things considered equal, if you're producing more better parts rather than just saying I want to produce more parts as a whole, your throughput is going to go up. So all of those things I think are kind of the hidden factors in ROI. But in general, I think most of our projects, when all the dollars and cents shake out, we look at around an average of 12 months, and that's usually a good target for manufacturers. I've had projects, particularly in operations where you're running 24 hours a day, you have 3 shifts. Obviously, that's going to bring the ROI in pretty close or make it pretty tight. And so we'll have people get it down to 8 or 9 months. And then for some folks, depending on the size of your operation, size of your company, some people are happy with seeing that return on investment in 16 months, right? It really just depends on kind of what your goals are. And then also, again, how important to your business is getting this process more efficient, higher quality, and again, at the end of the day, safer, for your operators that remain in that area or in your plant.
Do you find that going into it and some of those scoping conversations, do you find that people already have a lot of that data to start with, as far as understanding kind of your baseline of where you are, right? Because if you have a place you're trying to go to, some of those data points are going to be important to show you the actual value proposition. Do you find most people come to the table with that type of information, or do you encourage them to collect some of that information or go back to understand really what their opportunity or the size of the opportunity is?
Yeah. So, I think you see this a couple different ways. So sometimes you get folks who they're kind of diving into automation. There's been some corporate initiative, or if it's a smaller company, the owner of the company says, hey, we got to automate, we got to change some things. And so, you'll go on the plant visit and they'll walk you straight to the most difficult, biggest pain point, worst possible robot application in the plant and say, this is what we got to fix. And sometimes it's a home run, and sometimes it says, hey, we got just the thing for you, whether it's collaborative robots or otherwise. But sometimes, we say, what else you got going on? If your kind of goal is to automate, maybe let's try to find a more fitted application. Typically, if folks have an application in mind to bring it to you, they've at least thought about that ROI. Typically, some of the easier metrics to grab, like I said, what's your labor burden in that area, how many shifts you're running, all that stuff. Most production management, production engineers are going to know off the top of their head exactly how much it's costing them a day to run that area. But I think the other big thing with cobots in general and even automation at large is you don't know what you don't know. And what I find really interesting and like really cool about my job is when we do bring this technology in, we usually start from very basic first principles, task analysis, time studies, and we say, okay, what task is the human operator doing? What task can the robot do? And what tools is the robot going to need to do them? I think what's cool is people, encounter things they never even thought about in their ROI. Like, what if this process looked totally different, right? Like, because we're using a robot and not a human operator here, um, you know, the space between our presenting our parts and the grinding wheel can be totally different, right? The amount of time we're spending replacing equipment. I keep going back to grinding because I'm working on a project like that right now. But the efficiency and the amount of time and the amount of work I get out of one grinding wheel is totally different now compared to human operators. So things you couldn't even anticipate it now become a part of your ROI, because now your process is more repeatable. We can control it with more force. And again, that's something you would never know until you just kind of took the jump off the deep end and said, hey, let's investigate this area and get some other resources involved, some other professionals involved that could understand, hey, here's a way you could do this totally differently than you're doing it right now.
Yeah, that's a really interesting point, because you do tend to think, to the phrase that you don't like, the plug and play. We often think it's kind of a very enclosed solution, but to your point, it really is a catalyst for some innovation around your processes as a whole. And that's probably something that definitely doesn't get discussed. The technology gets discussed and the upfront benefits get discussed, but you don't really look at how that might shift the thinking overall organizationally, right, about how they approach their processes. So that's really awesome that benefit is there. It's good to share that too for folks that maybe aren't ready yet or have been thinking about it and don't realize just the full scope of what that can do for you. One question though is, do you see, and you may not have, a specific data on it, but what's your feel as far as where manufacturers currently are in adoption? Are we seeing more of the mature, large organizations, large, like you say, corporate initiatives sometimes drive that type of automation and innovation? Do you see it still heavy with the larger manufacturers, or do we have some smaller manufacturers that are now ready to embrace the possibility of implementing cobots and automation in their processes? What are you really seeing? What's the pulse there in industry right now?
So I would say, in general, if you think about the cobot market globally, I can assure you there are plenty of large manufacturers that are putting cobots anywhere and everywhere they can in their facilities, whether that be driven by, again, it almost feels cliche at this point, by labor shortages, or even just trouble retaining individuals that have been trained in a certain area, things like that. So it certainly has been, and still continues to be a large part of, the larger corporations, larger manufacturing outfits. But I think what's interesting about, you bring up kind of smaller to medium-sized manufacturers, uh, the expertise and the level of ownership in those places sometimes, in my opinion, is even higher than it is in kind of just your Fortune 200 large manufacturers, right? The reason I point that out is because the process expertise really is kind of what makes or breaks a project often, right? So we're coming in and, we're an automation distributor. We have a ton of resources. We have a ton of time and expertise with these robots, with all these different technologies. But we don't know your process. We don't know the intricacies of making golf balls or making car tires or whatever, right? So, the question is how do we collaborate on that? And what I've found is, like I said, sometimes in a smaller outfit, you have somebody who maybe was there since the inception of the company, or you have somebody who's there who's been doing that job for a really long time. And so again, if that expert knowledge about a process or a product is, a big piece of the pie, certainly small to medium firms have that ability to bring that to the table. Even if you think about a larger corporation, one of the things that has been a trend over the last probably 2 to 3 decades is even those larger firms are still kind of farming out their automation expertise. So when you think about a company like mine, where we support the distribution of automation products, whether it be robotics or pneumatics or whatever, a lot of times we're acting as an extension of the engineering team at the plant level. So it's even if that company has folks who are well versed in all these things, maybe they don't have time. And so, whether it's a large company or a small company, I think the dynamic there is really the same as kind of they bring the process knowledge, we bring the robots, and we see what happens from there. But it really can't happen without that process knowledge. We can't automate something that is not well understood by at least one stakeholder in the process. So you got to know what good looks like.
Yeah, absolutely. I would imagine, like, to your point, the smaller manufacturers have a lot more at stake too by jumping in feet first by doing something with a cobot. So their time investment and focus on making sure it's successful is going to be significantly higher, right, than maybe someone who's in a larger corporation that has a lot more capital available and a lot more support resources, to be fair. In the long term, like you said, if it's an extension of an engineering team, you still have people on site that can support it. So I'm sure the smaller folks are a little bit more focused on making sure it's successful the first time, which brings up a good point about things that when you start that implementation, are there, challenges, bumps in the road that happen as a project, implementation gets started? Are the things that some manufacturers run into that is kind of like, well, we need to back up, or wow, this is kind of a tripping point? Any thoughts on that, or things that you've seen, just in different projects that you've done that might be worth other listeners hearing about if they're considering it or just starting that process?
Yeah, so I think one of the things that automation does really well, but particularly on, I'm thinking of examples in my head right now with cobots, is making one step of a process more efficient or more repeatable or more accurate can sometimes expose other areas of that process that maybe should be more repeatable or should be more accurate. I think the easiest example of this is robotic palletizing, right? So you think about how many firms are out there that at the end of their line, they have some boxes coming down a conveyor and they have operators, doing a pretty low value task, which is picking that box up off the conveyor and putting it on a box. Labor resources are so precious right now. There are so many other higher value add tasks that can be done by that resource. And so we see robotic palletizing come up everywhere because, again, that's basically every plant everywhere. But one thing that comes up on these projects all the time is we'll start stacking the boxes. Maybe they'll send us a lot of boxes on a pallet and they're perfectly square and awesome and great because they came out of the good case packer, right? Rather than in the plant, you have 4 case packers and one of them makes boxes that are 8.5 by 11, and one of them makes boxes that are 8.5 by 12, right? And maybe that's only 12 in one corner. So when you start stacking these boxes up in a very repeatable fashion, right, where we're just going to a specific point in space and placing these boxes, what you find is the right side of your pallet is now 12 inches longer and it has an overhang, right? Because the case packer wasn't repeatable. And that's the same thing with all kinds of projects where you might, because now you don't necessarily have the adjustment that sometimes a human operator will make that'll say, well, this incoming part quality is kind of poor, but if I grind it a little more or do whatever with it, it'll all come out in the wash, right? But when you have a robot doing it and making it more repeatable, sometimes on the front end, you start to say, well, what else in this process, perhaps has some gaps or perhaps could be made better. So that's one thing. So you kind of start getting some upstream and downstream effects. The other big thing with implementation is, I think, we do as best of a job as we can on the front end of setting that expectation and, spending time in meetings talking about a million things that aren't robotics, because there's also stuff that people don't think about, like parts presentation, right? So, not to say that robotic bin picking doesn't exist. It certainly does. But, if you're going to bring a robot into an area, just dumping a bin full of parts on a table probably isn't going to be the fastest way for the robot to do that task. How are you going to present those parts? So sometimes those ancillary things will come up that you didn't even think about when you were thinking about putting a robot in an area. But that's why it's important to work with an automation partner who, has that experience and has the foresight to say, hey, this is probably going to be a problem for you in week 1 or 6 months from now or whatever.
I appreciate you bringing that up because I do think there's probably a lot of assumptions about because it's a collaborative robot, it doesn't mean that it has the ability to discern things, right? There's a certain level of intelligence that's not a part of that cobot, right? So it's relying on, like you said, part presentation or consistent box size. But we sometimes probably give far too much credit to technology that it's like all the things. It can discern whether or not this part's upside down or not. Not to say there's not, systems that can help with part presentation leading up to the cobot, right? But it doesn't have the intelligence to know the difference. And so it's going to do the operation it's told to do, but it may not do it well based on, like you said, the input to the process, right? So it's a very good point that you make, because we sometimes give technology way too much credit that it's going to be doing all these things, and it's not actually designed to do all those things. And you need to, put it in place for what it's actually designed for.
And one note on that, there are ways to bake some flexibility into these systems, which is another big thing for cobots, is really the flexibility of where I can deploy it. We work with contract manufacturers who say, okay, I'm on this project for 2 years, but what are we going to do after that, kind of thing. And so people like the ability to deploy the robots elsewhere. But even just all the things you can add into the cobot, whether that be like machine vision, right? So maybe we talked about part presentation. Maybe the part isn't presented perfectly every time, or the hole we're trying to put the screw in is not in the right spot every time. Vision's one way to get out of that. Some cobots, particularly universal robots that we work with, they have force torque sensors in the end of arm tool. So we can use that force to go and find like an insertion point, or to find a surface, or to understand, how much force we're applying during assembly. So there are ways, quote, to make it smarter. But even then, even with all the bells and whistles you can add on to a robot, one of the big things about industrial automation in general is the system only does what you tell it to do, right? So, you're correct that some people kind of get the thought wrong that, well, it's a collaborative robot, it's doing this process, it'll adjust to unforeseen circumstances, just like a person. And that's true if you told it to, right? But if you didn't tell it to, don't expect it to all of a sudden start learning something new.
Right, right. And one thing I before we close, I did want to ask you, because we covered a lot of ground, but if you had to give advice to, and especially our audience tends to be small to medium sized manufacturers. Obviously, there's a lot of large manufacturers we work with as well, but kind of that small to medium size. What kind of advice would you give based on your years of experience and the different use cases you've seen if someone's really on the cusp of making a decision of, let's take that next step and start talking to somebody about integrating a cobot? Any additional, I know we talked about a lot of different circumstances and things to consider, but is there any just really pointed advice that you would give them when they're in that phase of consideration?
Yeah, I would say, particularly if this is a firm that's, never kind of taken that leap with robotics, I would say the first thing is to, be open to feedback about your process, be open to taking on opportunities that, may not be, like I said earlier, the biggest pain point you have, right? I think a lot of people let the highest ROI and the biggest problem section of their plant prevent them from automating other things, right? I think, I talked about palletizing earlier and the robot stacking boxes. Pretty simple task at most, unless you just have a crazy fast production line. At most, you're maybe reducing, one particular operator in that area or something like that. But the number of people who I've seen who have gotten their, dipped their toe in the water with a simple task like that, and then 1-2 years later down the road, they're already automating 5 or 6 other tasks with cobots, is tale as old as time. So I think my biggest piece of advice is don't let great be the enemy of good, right? Don't let the biggest and flashiest opportunity prevent you from going and trying other areas of your plant that, one, are going to provide value, no matter what. If you're doing that, again, maybe it's on your Pareto analysis, maybe it's your second or third highest value in terms of automating something. But if you can take that leap, you can get that in-house knowledge, get your folks trained up on a particular technology or particular platform. that's really your highest resource expenditure is right there at the beginning. So pick a winner for that first implementation. And then after that, you'll see the projects roll in. And even then, you'll see projects that you never even considered. We walk into a plant all the time. They say, these are the only 3 areas we're looking at, right? And we do that. We get a project going. The project works great. Operators get familiar with the cobot. Technicians get familiar with the cobot. And when we come 6 months later, they say, we have 5 new things we want to look at because we understand this now. So to me, like I said, dive in, find a good winner for a first application, partner with an automation professional. And again, let companies like ourselves be a resource to kind of offload, whether that be time or knowledge, offload some of that work to get you, across the finish line on that first project.
I think that's great information. Success always breeds success, right? So like you said, pick a winner and don't be ashamed to play small ball. It's a bunch of small wins, right? That's true for everything. And we look at a lot of processes the same way in what we do as well. So I think that's wise advice. And, hopefully those folks that may be considering that will take a broader look at the operations they currently have and maybe where they could get some potential benefits. So I appreciate you sharing that. Chase, I just want to say thank you so much for being on the show. I think there's a lot of things there that people can gain from your experience and the different applications that you've used cobots in. I think that automation is definitely some of that low-hanging fruit for a lot of folks. And it comes down to really just understanding how to even approach that issue, right? So I think you've provided a lot of great information today. So thank you so much.
Yep. Thanks for having me.
Thanks for listening to this episode of the 6 M's of Manufacturing podcast. Thanks to Chase Wentzky for sharing his perspective and expertise related to the do's and don'ts of cobot implementation. Visit the episode notes for details and reference links to information shared during today's discussion. Did you enjoy this episode? That's awesome. Follow our podcast and share with your network. And remember, don't just make it better.